Hey guys, my name is Alex. I'm a student here at Johns Hopkins, and today we're going to get you guys prepared to do the first lab. So for this lab, what you guys are going to be doing is measuring the distance between these 2 points using math and trigonometry. The problem is that you guys are also going to have to track the error associated with this measurement, and in this measurement you guys are going to have to use trig and all those other things. The problem is that although in class you guys have seen how to do errors associated with like addition, subtraction, etc., which are pretty easy, this one requires trig functions. So the question is, how do you track errors associated with trig functions? So we can start out by doing a pretty basic example. Let's say you want to go find the height of something for whatever reason you have. Let's say you want to find like the height of your girlfriend or something, so you can go buy her a really cool custom-made dress. So you have the ground and you have your girlfriend. So to figure out her height using math, it's an 8th grade problem, right? You just go out some distance d from her. You measure the angle from the ground to the top of her head. Call the angle, say, theta. And since she has some height h, we can say that h is going to be equal to d times the tangent of theta. And, well, that's it. But what happens if we have some sort of error associated with our measurements? Because, you know, we're not perfect. So we'll have d plus or minus some delta d and some theta plus or minus delta theta. What this will create, of course, is, no duh, some h plus or minus delta h. So the question becomes, how do you find this guy? How do you find delta h? And when doing these kinds of derivations, the first thing you should do is to return to the original equation up here. So let's take the upper bound of the error. So we can say that h plus delta h is going to be equal to d plus delta d, the entire thing, times the tangent of theta plus delta theta. So we see here that h is equal to d times the tangent of theta. What we can do, therefore, is if we can somehow break this guy up into tangents of just theta and tangents of just delta theta, we can subtract this guy over to the other side and isolate him by himself. So the question is, well, okay, first thing, how do you break this guy up? Tangent of a plus b does not equal tangent of a plus a tangent of b. That's like really not cool. So what we can do is we can return to some formulas that you guys, I'm pretty sure I've seen in Algebra 2 and Trig. So to do this derivation, which I'm not going to show you because it's pretty quick and also I don't have that much time, what you can do is say tangent of a plus b is equal to sine of a plus b over cosine of a plus b. It's kind of simple, right? We know from Algebra 2 and Trig, the sine of a plus b is going to equal this formula, and cosine of a plus b is going to be equal to this formula. The key to this entire derivation, though, is to divide both the numerator and the denominator by this term here. If you divide every single thing here by cosines, what you're going to be left with is this formula right here. It makes sense, right? Because you're going to be left with tangents up here and tangents over on the other side, and then just tangents on the bottom, if it fills what we want to do. So using this formula and substituting in what we want, we find the tangent of theta plus delta theta is going to be equal to tangent of theta plus tangent of delta theta all over 1 minus tangent of theta times the tangent of delta theta. All right. So from here, we can make a simple approximation. And if you guys haven't seen this before, you're going to have to like take my word on it. Although you can just verify this on your graphing calculator if you want to. So it turns out we can use this one right here. That says that if tangent of theta is really small, as in like if your theta is really small, tangent of theta around the origin behaves quite linearly, as in tangent of theta kind of looks like theta itself. So we can make that approximation here because delta theta is a really small number, right? We're assuming it's really small in comparison to theta. So if that's the case, we can say that this is approximately equal to tangent of theta plus just delta theta over, we do the same thing for the bottom, delta theta times tangent of theta. Like so. Cool. So we've divided the tangent of theta plus something else up into tangents of just theta. So now we can plug this formula back up into this formula and then multiply through. So we can say that delta H is going to be equal to, I'm going to move the H over to the other side right now. So it's going to be d plus delta d times that formula, tangent of theta plus delta theta, all over 1 minus delta theta tangent of theta minus d tangent of theta. So now we can multiply this through. So then the numerator of this fraction over here will become d tangent of theta plus delta theta times d plus delta d tangent of theta plus delta d delta theta and then I also want to combine this term in with this. The denominator of this term is going to be 1 minus delta theta tangent of theta, right? No doubt. It's just simple algebra we're doing here. If we want to combine this term in with this term, we're going to have to multiply this numerator by this denominator. So that will give us a d tan theta on top and a d delta theta tangent squared of theta. All over the same denominator. 1 minus delta theta, tangent of theta. All right, cool. So now we can do two things. Well, first, we notice that the d tangent of theta over here is positive, and over here is going to be negative. So we can just cancel them out. And that's cool. It makes our lives easier. Also, don't forget to distribute this in. This will become a plus. And then the last thing we can do deals with this term over here. We notice that in comparison to the rest of the terms in this equation, delta d and delta theta are both really small numbers. In comparison to, say, this term, where you have just one delta times a pretty big number, we're assuming that your d is going to be sufficiently large. This term is going to be really, really, really small, right? Because a really small number times a really small number is going to get you a really, really small number, or one that almost approaches 0. It won't really matter in the grand scheme of things. So therefore, we can just approximate this guy, just for this equation, to be equal to 0. So we can cancel them out. And cool. That means we can combine these two to get our answer. So we can say that delta H is going to be equal to d delta theta, this is the first term, plus delta d tangent of theta plus d delta theta tangent squared theta, and the entire thing over 1 minus delta theta tangent of theta. And there we have it, our answer. And that is the error that's going to be associated with measuring the height of your girlfriend. So there's like 3 things you want to take out from this video if you want to retain it for future reference. 1, if you have tangent of a really small number, you can usually approximate that thing to being the really small number itself. Secondly, if you have something like two deltas multiplied by each other, where in comparison to the other things in the equation, they're not going to be very big. You have like a really small number times a really small number, you can approximate that thing to be equal to 0. And the last thing you want to remember is that when you're faced with some kind of evil derivation like this, always return to the original equation and work from there to figure out your error term. Right? Cool. So, well, good luck with the lab, and I'll see you guys next time.